This is my circular motion reassessment, and we're going to see how fast the ball has to be and where it has to be to snap. And then the mass of the ball is 1 kilogram. And then that's the gravitational weight when it's up top, and the tension. They're both pointing down to make up the radius, and the radius is 0.5 meters. And when it's to the side, the only other thing that's on the ball is the gravity has no effect on the side because the string is really not even tension. It has leverage in it pretty much. But when it's on the bottom, the tension has to make up all this, and that's the gravity on it. So I come over here and I wrote down everything I knew. Tension equals 75 in newtons. We just need to know when it snaps, and the string has to snap when it's at the bottom because that's when it has the most tension. So I put the central force equals the F net, and then I put the mass times the vector square over the radius equals the tension minus the gravitational force right here. And then I rewrote it pretty much, but I put the numbers to take out the tension. That's the tension number, and that's the gravitational number. And I times and I got numbers. And after that, I wrote everything down to get the vector on this side by itself, but it's so squared. And then the mass is 1, so it just pretty much cancel out because it ain't gonna do nothing. So the mass doesn't really even matter, to tell you the truth, unless if it's 2 or 3 or 4, Then when I got that number, I had 32.6, but I had to square it to get the square root out right here. So I squared it, and I got 5.71 minutes per second. And whenever it gets faster than 5.71, it will snap. And that's my reassessment for circular motion.